Hi everyone, I'm Goyal. I'm going to be talking about a project called Refigure, which I co-founded with James Aiken, who's also in the audience today. So in the discussion part of the seminar, please catch either one of us. I'm coming from a different perspective. I am a scientist by trade, so I spend a lot of time on the bench, and so I'm going to sort of describe to what the publishing model looked like to us. So this is what I spend my time doing. I read, discover, and interpret literature. I experiment, I generate data, and then I analyze it using various software, and then I interpret the findings. And I have to repeat with the current traditional publication sort of paradigm, I have to repeat this cycle hundreds of times before I even engage with the publishing industry. So you can imagine the loss of information that's happening. The loss happens because I don't document it. The loss happens because it's just in my head. The loss happens because, as I will show you in the next slide, because traditional publishing of scientific articles only accepts certain types of data. And from our perspective, the reason this is sort of an inside joke for us, we would then combine this years of data into a Microsoft Word document, and we would sort of send it into what was essentially a black hole. We somewhat knew what was happening to it, that it was going to peer review and things like that, but so we were completely disconnected. So there was a huge disconnect between the scientific output that I produce as my fellow scientists produce every single day, and the scientific publishing. And so just an example of the disconnect and our frustration. So we deal in data, we deal in hypothesis, but apparently it turns out data is not enough. You need a story to get published. And forcing data into story often leads to 80% of the data being ignored, because you have to find pieces that fit. Then you try to get the story published, and if it gets published behind a paywall, much of the interested parties will never actually see it. I grew up in India, so this is a particular pain point for me, that had it not been for many sorts of some luck, some lot of hard work, I would never have been at an institution which would have access to many paywall articles. And if it's published as open access, you're grateful that 20% of your efforts got out. So when Joe and I started looking at it, we felt that as scientists we were producers of the information, and as scientists we were consumers of the information. And the publishers were not really addressing our needs as service providers in the flow of this information and marketing this information. So Refigure aims to capture information which doesn't enter the conventional publication cycle. So I've sort of highlighted the 3 points where we want to do it. When I read, discover, and interpret literature, I want my interpretations, I want them out open access so that people can discuss them. I can talk to my community. Same thing about my own data as well as the analysis. So I'm just going to give you a brief demo, and then I'm going to take you through, just talk you through, I have no more slides actually, why we chose to go open access. So imagine now, let's consider an example where I am reading literature. So here I have 3 papers open on lymphatic transport, which is one of my things as a scientist. And one is from eLife, one is from PLOS, and one is from PMC, which are the 3 platforms we are supporting right now. So PMC allows us to hit many of the open access literatures. This project's actually supported partially by the eLife Innovation Fund, and they have really worked with us to make it workable. And we also did the same thing, made it work on PLOS as well. Okay, so I'm reading these 3 articles. The first thing you'll notice is that I have this refigure Chrome extension installed. And when I click on it, it tells me a few different things. It tells me that people have previously linked figures using refigure to other publications. This is very important information. Imagine when you cite, I don't know how many scientists are here or read the paper, but this is sort of citations on steroids. Normally when you cite, it's sort of left to the user to actually go dig up the citation. This is actually linking the data due to which the citation is happening. So we can link figures. We can link figures based on reproducibility. So we can create a dashboard showing all reproductions of an experiment in literature coming from different labs, for instance. So anyway, so I see that other people have already created some refigures. Maybe I can go look at them. But what I want, I'm here today to create a new meta publication which is citable, in which I want to highlight this particular scientific problem, the in vitro models of lymphatic transport. So I click, wrong, right-clicked it. Or I guess it's not working, huh? Is it okay? Oh, yeah, so I click create new refigure. I can put whatever title, etc. I want, hypothesis, keywords, and I hit create. And what I'm able to do with a single click is actually submit figures from any open access publication on PMC, eLife, and PLOS to this platform. And what essentially happens is that now you've given the scientist a way to create a meta publication which is citable, which they can get credit for, where this information that I would have acquired in my day-to-day activities anyway, that what I'm reading this literature, this is my interpretations, or these are my connections, immediately becomes available as a pretty neat looking publication. And not only that, it captures all of the metadata, so that we had to work pretty hard, and it turned out that we had to solve that problem for anyone who's interested on a platform basis, basically redo the code every time for every platform. But so we created, we capture all the metadata, including the figure legend, the DOI, the authors, and I can also put down whatever I want to say about those figures. In this case, I'm sort of putting down what cells were used, what devices were used, etc. And then I can look at those figures in very high resolution if I wanted. So this is just one of the ways that refigure allows you to capture the information. So this is an example of here. I'm starting a project. I want to capture all this information and make it available to the next person who comes around. All right. So why did we choose to go open access? The first thing is that that's where we found most traction. Turns out the people who most care about open science are also sometimes the people who most care about open source. So we got a lot of support from Mozilla Science Lab as well as Force 11, where it was the same community. We also found that it was just easier to build a community around this problem if it was open source. When we went to people and, if we just started saying, oh, we're building a different product, they didn't want to hear that. Many of the challenges and the other reasons to go open source are discussed here. One of the other things was that we didn't want the project to languish. We didn't want to be these sole sort of lone pioneers trying to push this thing through. So as a result of being open source, we found a lot of support. People, they might code, they might not, but they bring lots of different support. There were some disadvantages. We have to really put a lot of effort into building the community. It's just not a matter of paying someone and getting it done. You have to do it. And then monetization is a problem. So especially when you build for us, especially if you build something open source, How are you going to monetize it? Are you going to apply for grants as a nonprofit, for instance, or are you going to apply to venture capital firms? Like, this is the sort of question we run into. So that's just a very short overview from sort of our perspective as scientists and as people who have tried to address one small part of the problem. All right.